Hello, and welcome back to another episode of Kerbal Space Programming. Kevin here, and I am really excited to be back. It has been a few months, excited to pick things up. I want to warn you ahead of time, though, that the reason that I was away for a while is because I was moving, kind of traveling across the United States, ended up shipping out a bunch of stuff, and I want to warn you ahead of time that this episode, we're not really going to be going to space today. There are a couple of reasons for that. One is that when we last left off, we were on a completely different version of KSP, and I have to upgrade all of the mods and everything, get all of that sort of stuff configured. The second is that, unfortunately, when I was traveling, I had my PC tower shipped, and it did not entirely survive the journey. So I have some stuff that is on its way, and I'm still working on getting that whole thing set back up so that I can actually record the KSP game itself. But also, there is going to be soon a release of KOS 1.0. They've put out a release candidate, which is available for testing. If you look on the subreddit or you look at their GitHub page, you can go ahead and grab the release, and it's out. It's basically people who want to pull it down and try and break things and find bugs before they release it can go ahead and do that. But I don't want to go ahead and jump right back into writing code for these missions if we're going to end up, maybe having some optimizations and stuff that we can do on that code down the road. So instead, what I want to talk about today, and probably for a few episodes as I sort of ease back in and get set up and hope that that's enough time for KOS 1.0 to launch, is I want to talk a little bit about testing. Now, if you've used KOS, then you have done your testing. Your tests generally look like this: launch, wait, did explode, and then, repeat. This is your testing process. And this is really what we would call an integration test. You're testing the entire system all at once, seeing, hey, did that do what it was supposed to do? It's not going to give you many details about what went wrong. Sometimes you'll get some nice error messages from KOS because they're good like that. But, that's pretty much our process of testing. And it's not an automated process. It is very much a manual process. We automate the actual flying, but we have to set these tests up, and we have to figure out where these things are going. I want to talk a little bit about why I think the testing is important, because I know sometimes it can seem like a bit of a dull subject. So there are a couple of things that I really like about testing. So the first thing, let me give it a headline: testing with a lot of exclamation points to make it seem exciting. So number one is that that your code works. At whatever level you're testing, that at least for the cases that you've thought of that you have written tests for, well, if it works, or if it doesn't. That's kind of the more important thing. If things aren't going to work, you'd rather know ahead of time rather than when you're out around Joule and there's no connection, you go, oh, you know what? I should have thought of that one edge case. And that certainly happened to us in this series. We've run into cases where it is a very inconvenient time to discover that there is a bug in our code, and yet we didn't have any tests to catch that ahead of time. The second thing, and particularly with a newer version of KOS potentially coming out, is dependencies. Now, this could be with KOS. This could be with some of the libraries that are up on KSLib. It could be some code that you found from somebody else. If you go ahead and update those dependencies, so if I go ahead and update from KOS, 0.19 to 0.2, whatever it is, and eventually to KOS 1.0, is my code still going to work? I don't necessarily know. But if I have tests, then I can go ahead and run these tests that I knew passed before, and I can figure out, well, hey, the stuff still seems to be going well, so I can be reasonably confident that the stuff I wrote before is going to be just fine. Now, the third reason is a little more subtle, but it actually has to do with code design. So occasionally, if you're writing code, and this is true kind of if you're doing KOS stuff, if you're programming in really any sort of programming language, occasionally you have this flash of insight. And all of a sudden you just start writing a whole bunch of different code, you have crazy math, and it goes insane, and you run it and it doesn't quite work, and you go, okay, well, maybe I'll go ahead and, this shouldn't be a, I capitalized. There we go. This shouldn't be a less than or equal to. This should be just a less than. Or no, that still doesn't work. All right, well, let's go ahead and delete this, and we'll delete a whole bunch of random lines, and maybe split that up, and whatever the heck. And eventually, you end up with this blob, this wonderful piece of code that barely manages to do whatever this big thing is that you wanted to do. And a lot of times it's, maybe just you're going ahead and trying to get something to get off of the launch pad. You go ahead and you write a bunch of code and you go, okay, finally it works. You've made all of these modifications and you don't exactly know what it is that you did, but it manages to work in this one case. And then the problem is that a week down the road, or even the next time you launch something, it doesn't quite work. You've come up into some other case and you go, shoot, I have absolutely no idea what this code was even supposed to do in the first place. So you don't even know how to fix it when it goes wrong. The thing that I've discovered writing code, particularly test first, is that when you're writing your tests, you are describing exactly what your code is supposed to do. And on the one hand, that means that your test should tell you what your code does. But on the other hand, it also means that you're designing your code in a way that matches those tests. You're designing your code to do one very specific job. You're not going to end up with this big cluster of code. You're going to have, small thing. It's like return 5. That's a terrible example, but whatever it is, you're going to end up with much smaller functions because it's a pain to test very complicated stuff. Who knows what all of this crazy code is going to be? I need to get better at writing pseudocode, but nobody knows what that's all going to be, and it'd be very difficult to write tests for. So when you're trying to force yourself to write tests, it makes you write simpler code. So how do we actually go about this sort of thing in KOS? No more flash of insight. So a good test, let's go ahead and write a function. We're going to call it function my first test. A good test has really 3 steps. The first step is you create some stuff. Okay, so let's go ahead and imagine that I'm going to say local Jeb is make Kerbal. We'll imagine that there's some function called make Kerbal that makes a Kerbal. And then the second step is you're going to do something to that stuff. And so it would say Jeb, let's assume that we got back some sort of lexicon in KOS, and let's see, Jeb go to space, and would run that function. Now the third step is check the result. And so obviously the result here would be, print Jeb is stranded on Minmus. Or we would really sort of expect that to be true. This is the core of what you have in a test, is that you say, here are some starting conditions for my test right here at the top, this number 1. We create some stuff. We say, I've got some Kerbal. Maybe he has a name. Maybe we give him a name, or maybe there's some particulars about creating this thing. Then we go ahead and we say, here's the thing that I want to test. I want to test what happens when I do this to these objects that I've created. And then I want to say, okay, did the thing that I thought was going to happen, did that happen? Because if it didn't, then it means there's something wrong with my code. Now, there is a problem here with particularly this line. And I'm pseudocoding this. This isn't supposed to run or anything. But I don't like this third line. And there's a reason for that. It's that I'm just printing out the result. Now, that means that I have to look and I have to know what I expected to happen. So if I were to go ahead and run this, my first test, and actually I could run this because I do have a very bad iffy version. All right, so it's going to give us an error that make Kerbal doesn't exist. Let's go ahead and create that really quickly. Make Kerbal. We'll just do that. It's not going to do anything. Yeah, we'll just leave it there. And we'll see, will this run? Can't iterate on it. Yep, it doesn't have a thing because, yep, we had no return value. Okay, so we've got to make this pass. We've got to return. Let's return a lexicon. And let's see, what should it do? Let's say go to space is going to return make Kerbal. We're just going to return ourselves. And then was there some other thing? Yeah, is stranded on Minimus is going to be another one. Is stranded on Minimus, question mark, and make Kerbal as well. We'll do that. Right? Yeah, that looks right, I think, maybe. I don't know why I'm trying to make this pseudocode pass. Okay, there we go. Now, this code actually ran, which is really stupid because it was a bad example, but it's printing out this result. Now, I don't care what this result is. I do care what it is. I care that it returns something true. I want to make sure that Jeb is stranded on Minmus. I expect that if he goes to space, that is the logical result. Well, so how would I go about actually testing that? if I, let's change this real quick. I'm going to go ahead and add another function. I'm just going to say return, be true. And this is just going to return true. Because is stranded on Mimus shouldn't be returning a Kerbal. It should be returning, let's see. Yeah, it should be returning true. So if I go ahead and run this now, there we go. Okay, so the result that we get is true. It prints out true. So if I'm a smart person and I've just looked at my tests and I run my test and I go, okay, I expected the system to print true one time, then I know that it passed. Of course, if it didn't, if I change this to return false, I'm not going to get any sort of error. It is just going to print out false. And that's not particularly helpful. At least it doesn't seem like that to me. We'll go ahead and undo that. So really, instead, what I would rather have is some way of saying, this is what my expectation is supposed to be. And in a lot of other languages that deal with testing, you have this idea of an assertion. So instead, I mean, I could go ahead and change this. So, like if not Jeb is stranded on Minmus, then print, and I'd have to call that, not with the dot, print, he's supposed to be on Minus. He's supposed to be on Minus, etc. But that'd get kind of unwieldy if I'm writing a whole bunch of these. If I'm writing a whole bunch of tests and I don't want to do all of these random conditions, what I would rather do is I'd just like to say, assert Jeb is stranded on Minus. And do that. So all that I'm doing is I'm saying this is what I expect to have happened. And I don't want to tell you what you're supposed to do. I don't want to tell the test framework kind of how it's supposed to handle that not being the case. I just want to say, here's what I expect. And then you deal with the results if that's not true. If I go ahead and run this, of course, this is not going to be happy. Yeah, so it's mad. Okay, it's mad for other reasons. I don't know why. What? Jeb is stranded on Minmus, which is stranded on Minmus. Oh, yep, there's a question mark supposed to be there. Okay, so that failed for the wrong reason. There we go, undefined variable assert. So, okay. Gone kind of crazy into this example, but let's go a little bit further. I want to go ahead and create this function called assert. Because assert could be a function that's not specific to this pseudocode example. This is an example where this is a function where we could actually use this across a bunch of different tests. I'm going to go ahead and create this. Let's see. So it's got to accept some parameter, right? If I go ahead and say parameter, and let's be really fancy, let's call it postulate, from the philosophy of this is the thing that could be proved or disproved. So it's going to take a parameter postulate. And we know that what we're getting here is that one argument. Let's see, postulate 13, thank you. And now we have to figure out what we want to do here. So we could do exactly what I started to type out. We could say, if not postulate, then print, something's broken. And there we go. Okay, so if I go ahead and run this now, yep, program ended. So nothing went wrong. But if I go ahead and break be true now, and go ahead and try and run us again, something is broken. We expected Jeb to be stranded on Minmus. Jeb was not stranded on Minmus. So that's not great. So now we at least have something that we can sort of use. But I'm still not a huge fan of this because especially if I'm running a bunch of different tests in a file, then I end up in this spot where I may be printing out a bunch of stuff and it could get all sort of clobbered. What I really want to do is I want to say, hey, if the assertion failed, we should be raising some sort of error, right? So I'm actually going to go ahead and get rid of our first test stuff and just play around with this assert function for a little bit. Let's go ahead and just use a very simple example. Assert 1 plus 1 equals 2. Now, of course, we're not actually passing. Remember, this whole thing gets evaluated. So really what this resolves down to is assert true, which is just fine by us. So we're going to go ahead and do that. And I'm also going to add assert 1 plus 1 equals 3. And of course, if we run this, something is broken. Okay, it didn't flicker, but yeah, there we go. Something is still broken. And if we removed this one, I'm sure things will be fine. I hope. Please. Okay, good. Things are fine. Let's go ahead and pull this back. So the problem here, though, is let's say now I have 2 plus 2 is 4. And let's go ahead and run this. And something is broken, but we have no idea what that thing is. And that is incredibly frustrating. So instead of actually just printing something out, what I would rather do is throw an error. Now, this gets into something that is not part of KOS at the moment, and not something that is going to be coming out in this next release. In a lot of languages, you'll have this idea, let me put it up here. You'll have this idea of a try-catch block. And it goes something like this. So you say try, and then say print, hooray, or whatever code, and then have a catch and say print, something went wrong. And the idea is that if you have code that you think might throw some sort of error or might have some sort of problem, you put it inside this try brace. And then if any error happens, then you have this catch brace and that code will run. So this is a way that you can safely recover. Right now, if you have an error that causes KOS to crash, KOS is just going to crash. There's no way for you to recover cleanly from it. So if we wanted to say divide by 0, if you did that in a try-catch block in many other languages, it'd go, oh, you tried to divide by 0, disaster, and it'd go, okay, but you're inside a try-catch block, so we'll go ahead, we'll just say we're not going to run whatever, maybe after that, we'll jump immediately down here and go, something went wrong, but then we'll keep running, whatever code may exist down here. Now, this doesn't exist in KOS, and if it did, another thing that you might have would be a function like throw. Now, generally, throw or raise or code like this is to explicitly throw some sort of error that will get caught by a try-catch block. So what we'd love to be able to do is throw, something went wrong. And what that would do is immediately stop executing whatever, unless it was in a try-catch block, in which case it would be caught. But since we don't have try-catch blocks, we're just going to have to settle for throwing an error. So I'm going to go ahead and say throw something's broken. And let's see, let's make that a more useful name. So we'll say assert, let's say expected true to be false. That's the only thing that we actually know, because what's getting passed in here is something that's either true, false. Actually, we don't even need that, do we? Right. We're not expected true to be false. We expected false to be true. Okay, we'll say expected plus postulate plus to be true. So we'll print out whatever the thing was. We'll throw whatever the thing was. We'll say we expected it to be true. That's what our assert function does. If we go ahead and run this, throw does not exist. Undefined variable named throw. So we've got to go ahead and define that. So let's go ahead and write that. And this is going to have to take a parameter, message. And here's where things get a little bit difficult, because we don't have the ability to just crash KOS with a specific message. We can crash KOS, though, by trying to divide by 0, and so that's exactly what I'm going to do. I'm going to go ahead and I'm going to print the message, plus, let's see, char 10, I'm going to print a new line, plus a bunch of dashes, and then I'm going to try and print 1 divided by 0. Now, that means that KOS is going to crash with an error that doesn't have anything to do with what's going on. But hopefully, if we look at what happens, there we go. Okay, so expected false to be true, and then some dashes, and then try to push infinity on the stack, blah, 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 because it doesn't like us trying to divide by 0. And actually, if we look down at the stack now, we can see that we get the assert 1 plus 1 equals 3. That is where things ended up failing. So we actually sort of know now where things crash, because we're forcing a crash that really that shouldn't quite be there. If you can think of kind of a better message that we could throw, I mean, because there are certainly ways you can break KOS. That is a fun little project to play around with, certainly. But I think that's probably as good as we're going to get for the moment. Now, one thing that a lot of other languages have with what are called basic assertion libraries is they might have some sort of thing here where, because the error message that we got was expected expected false to be true. That's not particularly helpful. A lot of languages let you actually pass in a particular failure message to assert. So we might say here, maybe we don't care about 1 + 1 = 2, but we would say expected 1 + 1 to equal 3. Or would have the same thing here, expected 2 + 2 to equal 4. And if we go ahead and run this, well, now we're going to get more errors because the arguments that we passed in didn't match the arguments that were received. So I'm going to go ahead and add one here, an optional message. And let's go ahead and say is 0 as a default. Okay, now things crash in the same way that they did before, so we can go ahead and expand this. We could say, if not postulate, then okay, if there is not a message, that's actually, if message, then, let's see, throw message, else, else then do this. So if there's some sort of specific message that we passed in, then go ahead and use that. So let's see if this actually works. If I did that correctly, we'll have to find out. And there we go. Now we have a message that is what we sort of expect. We have this assertion and we were able to pass a specific failure message, but if we don't pass a failure message in, that's perfectly fine too. So we have this sort of optional argument that if we're doing something particularly complex, we might be asserting, like ship, name, part, module, something, where it's not necessarily clear. We don't want to just get a message that says true or false. We'd say, expected ship to have plutonium, or whatever the case may be for a particular test. Let's go ahead and remove that as well and just make sure that things still run just fine. There we go. So we still get the failure, but without the custom message. So we have the ability to put in both of those. Whoa. All right. So now the really cool thing is that now that we have these assertions, we can actually start using these in useful ways. So let's imagine that I have some sort of function has even, and this is going to take some sort of list. Actually, I'm not going to write the code for it. I'm just going to say it takes a list, returns whether any of them are even. Takes a list of numbers. Whoa. And returns whether any of them are even. So we're going to get rid of these really bad math example assertions. And I'm going to say, okay, so how would we go about testing this? I want to say assert, let's see, has even, let's say 2, 4, and 6. And expected even list to has even. That would be our failure message if this happens not to pass. Let's go ahead and run it and see what happens. Too many arguments. It's mad. Okay, that's fine. This is great because we're actually writing our test, and our test is now driving what we actually have to do to write our code. So I'm going to go ahead here and say, okay, we're going to have to take a parameter then. Whoops. Numbers. And all I'm going to do is I'm going to fix the error message that we got. I'm not going to try and actually write out the logic to do what we presumably actually need this thing to do. I'm just going to try and get this thing to run. Okay, no, now it's still mad. Why are you mad? Oh, right, because my test is wrong. I want to give it a list of stuff. I want to check has even, and I want to give it a list. And I want to make sure that it detects that, yes, there is an even number in that list. And there we go. Now we get the error message that we wrote, expected even list to has even, and that is not true. So, okay, how do we make this test pass? What is the bare minimum that we can do to make this test pass? Well, it's pretty simple. We'll just say return true, right? I mean, the search just wants this first argument to be true. I mean, that's all that we have. So yeah, we'll just return true. And then if we go ahead and do this, then the program ended and everything is super, super happy. Hooray for us. Now, of course, we want to write another test and we would say has even, but a list of maybe 1 and 3 and 5. Expected odd list, let's see, to not has even. So Now we've actually got to change what we're asserting here. Assert not has even. I think that should work, right? Yes, okay, expected odd list not has even. So that's now breaking. And now we go, okay, well, to make this actually pass, we'd do something like for n in numbers, if mod n divided by 2 equals 0, return true, because something in that list is divisible by 2, otherwise return false. And we go ahead and write the actual implementation. We go ahead and run our test, and everything is fine. So you see what we did, though, is that we actually drove most of this has even method just by going, well, how do we do the bare minimum that's actually going to make stuff pass? And that we can actually have these assertions about the behavior that validate that, yeah, we wrote it the right way. Now we can, if I wanted to go ahead and change this up, if I wanted to say instead return 0 and return 1, because I think those are probably the same as true and false, you know, is that still going to work? Is that going to pass? Well, I can go ahead and just run, and the test doesn't throw any errors. And so we go, okay, yeah, I could probably print something like done, so we can verify that it actually ran. There we go, we get done. And then I know that this function does what I expected it to do. Now, there are some things, though, that I'm not a huge fan of, particularly this assert not thing here. It feels like there probably should just be like an assert false, you know, around some sort of argument. Or maybe cases where I want to say assert equal, you know, ship name and my cool spaceship and that sort of thing. Whoa. But that is something that I think we're going to go ahead and push off until the next episode, because I really want to sort of expand out what we can do by writing these tests, and in particular using this test-driven idea to write these test functions, because I think this is going to help us out when we jump back into space. So I appreciate you watching, and I will see you all next week. Cheers.